everybody, and welcome to Echo Live. My name is Anna, coming to you from the Michigan Science Center's Echo Distance Learning Program. Today, we have another very cool virtual planetarium program all about exoplanets, presented by, of course, our staff astronomer and NASA Solar System Ambassador, Paulette. If you haven't done so already, go ahead and introduce yourself in the chat feature wherever you are watching from. Hello to everyone who's already doing a great job introducing themselves on Facebook, on YouTube, and right here inside Zoom. Use that chat feature throughout the program. You know that you can use it to ask Paulette questions about anything space related and anything about exoplanets that you might be curious about. But you can also answer Paulette's questions as well, because I know she has a few to ask you guys. So keep the chat going. I'll keep an eye on that. And with that, I'll let Paulette take it away.
All right. Hi, everybody. I'm glad to be back today talking about exoplanets. Exoplanets are also known as planets orbiting around other stars. So when we look into our virtual planetarium sky, we're able to see the stars up in our sky, as well as some of our planets in our solar system and our moon. But we have planets that are out there that are orbiting around a lot of these stars that we can see up in the nighttime sky. Now, tell me, what do you think we can find these exoplanets or these planets orbiting around other stars? How do you think we find these exoplanets? How do we usually look at things up in the nighttime sky? How do we get a closer look at some of the objects that we see? How might we be able to find some of these exoplanets or planets orbiting around other stars, so other solar systems that are out there? Well, we could use our telescopes. We could actually put our telescopes up to the sky to be able to see some of the other planets orbiting around other stars. So somebody said satellites. That's true. Some of the satellites that we send up into space are actually spacecraft that are orbiting our planet and looking out. So those are our space telescopes. But telescopes are a way that we can see them. And in fact, the Hubble Space Telescope, a telescope that we talk a lot about here on Echo Live, actually discovered one of our first exoplanets. They were also able to use a telescope in 1992 to spy 2 planets orbiting around a neutron star. So we were able to see exoplanets and know that planets are out there orbiting around other stars since 1992. And then in 1995, we discovered exoplanets in a different way. We discovered exoplanets by using something called the transit method. So let's go ahead and take a look at what that transit method is. All right, so right here, we have the brightness of a star. So that brightness will actually change over time if there is a planet that transits or moves in front of the star that's out there. So here we have our brightness line, and if there was no planet, it would be sort of straight across. But because there is a planet in the way, we have a dip in light because that planet actually stops some of the light from the star from reaching our eyes. So though we can't see this exoplanet specifically up close, this transit method that we discovered in 1995 was sort of like our first step to being able to see or find these exoplanets in space. Now, I want you to guess how many exoplanets or planets orbiting around other stars do you think we've discovered? So far, How many exoplanets do you think we've discovered? Someone go ahead and throw out a number. How many exoplanets do you think we have discovered, specifically using, or not just specifically using this transit method, but in general? How many exoplanets do you think we have been able to discover? Our friend Evan from Texas says 34 exoplanets. That's a really good guess. More. It's going to be even more than that. 2,000? Another really fantastic guess. It turns out that we've actually been able to see and able to find over 4,000 exoplanets. So exoplanets, planets orbiting around other stars, we've been able to find so far 4,164. And this is changing all the time. So what we see here, these brighter stars that we're able to see, are actually stars that have planets around them. So around 3,085 stars, we've been able to find 4,164 planets. Now, let's take a look at some of these more extreme planets. Now, one of the reasons that we're looking for exoplanets is we're looking for planets that are like our Earth. We're basically trying to see if there's life out there outside of our solar system. But some of the first exoplanets that we were finding were huge. This one, for example, is 6.9 times the radius of Jupiter, the largest planet in our solar system, and the mass is 752 Jupiters. This planet is huge. And these are some of, like I said, the first exoplanets that we were able to find because they have a larger light dip from the star that they're surrounding. But when we compare this solar system to our solar system, we're actually able to see that this planet is pretty far away from its star. So tell me, if it's far away from its star, is it going to be hot or is it going to be cool? That's far away from its star, far away from its light source or its heat source, all the way beyond the orbit of Uranus compared to our solar system, what do we think this exoplanet is like? Is it hot or is it cold? Really, really far out there. These exoplanets, really, really far out there, are going to be fairly cold because they're super far away from their star. And when we look at what the habitable zone is, or where life can actually exist, this is way, way outside that habitable zone. So, like I said, a lot of these exoplanets that we were first finding were the really, really big ones. So here we have another super Jovian super Jovian exoplanet. This one is only 3 times the size of Jupiter in radius, and it is about the mass of 20 Jupiter. So this one's a lot closer to the Jupiter that we know and love in our solar system. Now, you might notice that these planets that we're sort of looking at, they have art associated with them. This is a hypothetical visualization. So we don't actually know what these exoplanets look like, but we can guess what the exoplanets look like. And these are some artist renditions of what they look like. Now, some of these Jupiter or Jovian type planets that we're finding were very, very close to their stars. So here we have one of those Jovian planets, but look at how close to its star it is. So this one is probably very, very hot because of how close it is to its star. And if we take a look again at that thing that we call the habitable zone, so where life would be able to form, where it's not too hot, it's not too cold, we call it the Goldilocks zone, we're able to see that this one is way inside of that habitable zone. So it's going to be really, really hot on this exoplanet. Now, we've also been able to find some small exoplanets. We've been able to find some exoplanets that we call terrestrial, or the rocky planets, that are very, very similar to our Earth. So for example, this is one of those terrestrial planets, and the mass is over 3 times the size of the Earth. So this is Kepler 37b. Now, when we take a look at where it is compared to its habitable zone, unfortunately, Kepler 37b is still going to be fairly close to its sun. So it's going to be a very, very hot exoplanet. Some of the other ones that we are able to see, for example, let's look at this one right here. We have another one of those rocky planets. And this one, sort of a weird color, right? So we've actually been able to take a look at some of these exoplanets, and we've been able to figure out what their atmospheres are actually made out of, or what these planets could potentially be made out of. And we do that by using something called spectroscopy. Now, I know we've talked about light emission and spectroscopy before on Echo Live, but we're going to talk about it in a little bit of a different way. So when we look at stars and when you look at their spectrum, we see something that kind of looks like this. We can see all of those emitted lines, and we have these darker lines called absorption lines. This tells us what is inside of a star, what stars are made out of. If we compare the spectral lines of the star to the spectral lines that we see during the transit, then we can actually tell what's in the atmosphere of the planets that we're looking at. Some of those things might be the same, but a lot of them can be very, very different. And the thing that we're looking for most is liquid water. Why do you think we might be looking for liquid water on some of these exoplanets that we're trying to identify? Why might we be looking for liquid water? While you think about that, this process of spectroscopy was actually done a long time ago. Most of the stars that we can see up in the nighttime sky, this was done by hand and was done by a female astronomer, Annie Jump Cannon. So here we have Annie Jump Cannon, and she's looking at a plate of the spectrum, and she's comparing it to some of the other ones that she was able to see. Now, she was not looking for exoplanets and their atmospheres, but she was able to classify, like I said, most of the stars that we see up in the nighttime sky. She was one of the original computers that was out there. So why do you think we might be looking for liquid water? Some people say we need water to live. We need water to live. That's right. And if there's liquid water on an exoplanet that we're trying to find out in space, then we might be able to find life. There might be life out there on other planets. Now, a couple of years ago, we launched the Kepler Spacecraft. And that Kepler spacecraft was able to take a very close look at a very small area of the sky. So here we have that Kepler spacecraft, and it's actually a telescope that's looking for infrared and visible light. And there we go. Infrared or visible light, and we're able to see that Kepler telescope right here. Now, Kepler was a stationary telescope out in space that looked at a very small area of the sky right there. Does everybody see that area of the sky? Now, this area of the sky is very, very dense with exoplanets. And that's because the Kepler data, Kepler 1 and 2, that data was sort of the driving force behind finding exoplanets. And when you're only looking at a small area of the sky, you're going to find a lot of exoplanets in that very, very small area. But when we go ahead and zoom out a little bit, we're going to see where the Kepler missions were actually looking. So the Kepler missions were able to find some exoplanets out this direction and a little bit out off to the sides. But mostly, it was able to see a small swath of the sky in front of it. So we were able to see all of these exoplanets. All of these exoplanets that we talked about earlier, over 4,000 of them, just in a very small area of the sky. But how do you think this compares to the rest of our galaxy? What do we think? How does this compare to the rest of our galaxy? Well, if we zoom out, we're actually going to be able to see that the exoplanets that we see with the telescopes that we have on the Earth and surrounding the Earth, even out in space, are looking at a very, very small area of our Milky Way galaxy. There's about 300 billion stars or so inside of our Milky Way galaxy, and we're only looking at a very small portion of that. Now, what we are really looking for is we're looking for planets that are within what we call the habitable zone. They're not too hot, they're not too cold. They could possibly have life. Now, I actually know of one of these exoplanets that's within the habitable zone. So I'm just going to go ahead and search for it. And here we have the star TRAPPIST, TRAPPIST-1. This star actually has quite a few Earth-sized planets orbiting around it. So we have those Earth-sized planets. We have TRAPPIST-1b, C, D, E, F, G, and H. Now, the neat thing about this is if we actually bring up that habitable zone, and of course, it's going to move me around again. There we go. This star has, let's see, 1, 2, 3 planets, Earth-sized planets within the habitable zone. So this is a really good candidate to look closer and try and see if we can find a planet with liquid water or life. Now, the neat thing about this star is actually the distance from our sun. So this has 7 planets, and this star is 41 light years from the Earth. So the way that we measure distance in space is using the light year. The distance light travels in 1 year. So if this is 41 light years away from us, this might actually be within our radio transmission. So remember, we've talked about that electromagnetic spectrum and how radio is another form of light. We're not actually able to see it with our eyes, but it is upon the electromagnetic spectrum. It travels at the speed of light. Does anyone know, when did our radio transmissions start? When did we first send out radio broadcasting or our radio transmissions? Anybody know how long it's been since we started doing that? It's been since about, commercially, it's been since about the 1920s. So we have been sending radio waves out into space for 100 years. So if we think about it, this exoplanet right here, that's only 41 light years from Earth, is actually within that radio sphere. They might be listening or watching TV from us from a long time ago, from 41 years ago. And I think that's actually pretty interesting stuff. Now, we talked about all of the exoplanets that we have here in our, in our Milky Way galaxy. And again, we've really only discovered a very small portion of those exoplanets in our Milky Way galaxy. But we've actually been able to estimate how many other galaxies there are out there. There are, if we take a look at another image from our Hubble Space Telescope, I love the Hubble Space Telescope. It is definitely one of my favorites. If we look at this image from the Hubble Space Telescope, this took a very small area of the sky and it looked at it for the equivalent of a couple of weeks. And what it saw in that area of the sky were not just stars, but galaxies. So all of the things that we see in this image that don't have spikes coming off of them, so if you watched my Hubble Space Telescope program, you know that the ones with spikes coming off of them are stars. But everything else in this image are galaxies. So that's not, and that's not. And I think there's one more right there. Everything else in this image are galaxies. So we've estimated that there's about 600 billion galaxies out there. Each of those galaxies that we see are a giant collection of millions, billions, or trillions of stars. And if we assume that 1 in 5 stars have an exoplanet around them, think about how many planets there are outside of our solar system. It's crazy. Now, if you want to help scientists discover some of these exoplanets, there's a way. You don't have to be an astronomer to help out. There's something called a citizen science project. This one specifically is called Planet Hunters. This citizen science project allows everyone. It doesn't matter if you are a kid or if you're a grown-up, or if you are studying this in school, or if you're studying art, or if you're studying anything, or if you have a boring desk job. This would be a great thing. So this is Planet Hunters, and it is a citizen science project where you can help scientists discover these exoplanets. So the website actually takes you through the whole process, and you're able to find out and figure out how you can help find these exoplanets. For example, if we look at this one right here, What do you think? Do we think that this is an exoplanet? Or do we think this is maybe two stars orbiting around each other? So if we look at this one, do we think it's maybe two stars orbiting around each other? Do we think this might be an exoplanet? It turns out that even though this looks a lot like the transit method, this is actually two stars that are orbiting around each other. So this website, zooniverse.org/planet hunters, this will actually teach you how to go through and how to see a transit. And you can actually go through the data with the scientists to figure out if you're seeing an exoplanet or not. You can also chat with the research team and other volunteers that are helping out with this project. I love citizen science projects because it allows anyone, it doesn't matter if you have a degree in astronomy or not, it allows you to be part of the science. And I think that is super exciting and fun. All right, so does anybody have any questions today about the exoplanets that we have talked about? Anybody have any questions? And while we're waiting for some questions.
Of course, it's that time, guys. Just a couple reminders about our program. We are still looking for your feedback about Echo Live. Lots of you have been tuning in every single day since we got started. We'd love to know what you think about the programs. We want to know what things you still want us to present on. Tell us your favorite episodes. And you can do that by filling out our survey, which we've posted in the description to our last couple of videos. And of course, we'll post it with this one as well. So we're hoping that you guys will give us, oh my goodness, I can't get it to come up today. But we're hoping that you'll fill out that survey. It will be included in the link. And by doing that, you can also enter to win a free week of virtual summer camp with MySci Spark Camp. So virtual camps start the first full week of July. Registration links are up and are live, so you can register. Even if you'd like to enter to win a week, you can still register for a week of camp now to make sure you secure your spot. If you do win that free week of camp, we will work that out with you. Don't worry, but you don't want to miss your chance to win a free week of camp. So I highly recommend you sign up for all of our weeks of summer camp. Even if you're not anywhere near Michigan or the city of Detroit, you can still come to virtual summer camp with us. I'll be there, Paulette will be there, and some of our other MySci educators will be there as well. Paulette, do you see any questions coming up in the chat?
I don't see any questions, but I did want to mention something. The software that I've been using today is another free software. So I'll bring it up really quickly. So this software that we've been using today is something called NASA Eyes. So this one is specifically NASA Eyes on exoplanets. There's also NASA Eyes on the Earth and NASA Eyes on the solar system. You can find it by Googling NASA Eyes. It's official NASA software by NASA's JPL. And it is fantastic free software that you can use at home.
Very cool. All right, well, if you continue to have questions, if you watch this video later on or you think of something, you can still tell us in the comments, send us a message on Facebook or in YouTube. We'll check those out, and Paulette will keep an eye on those. And otherwise, we'll see you back here tomorrow at 2:30 p.m. for another